All right, we're in the second of two videos where we're looking at the review for test 1. So on number 9, we've got f of x equals x squared plus 5, and g of x equals 4x minus 3. So in A, we're supposed to find f plus g of negative 1. Now, as always, I would encourage you to try these and then watch the video. So here we know that f plus g of x by definition means f of x plus g of x. The only thing different here is instead of having an input of x, it's negative 1. So this becomes f of negative 1 plus g of negative 1. Well, I know how to find f of negative 1. I just plug it into the f function. It'll be negative 1 squared plus 5, which is 6. Now I'm going to find g of negative 1. It'll be 4 times negative 1 minus 3, which is negative 7. So we're going to have 6 plus negative 7, which is negative 1. On B, we have f minus g of x. So that by definition means f of x minus g of x. Well, we have two binomials here. We're going to want to put these in parentheses. It's going to be x squared plus 5 minus 4x minus 3. Now, the parentheses don't really matter here, but on the second parentheses, you're going to have to distribute the negative, so it makes a difference. If you don't use parentheses, you'll end up with the wrong answer there. So we end up with x squared plus 5 minus 4x plus 3, which, let's see, we only have one x squared term and only one x term. We can combine the 5 and 3, and we get 8. So x squared minus 4x plus 8. On letter C, we have f divide g of 0. Well, by definition, this is f of 0 over g of 0. If this had been f divide g of x, it would have been f of x over g of x. The only difference is the 0. Once again, I know how to find f of 0. Plug 0 into the f function, you get 0 squared plus 5, which is 5. For the g of 0, you plug 0 into the g function, you get 4 times 0 minus 3. Well, that's negative 3. So this is 5 over negative 3, which we would write as negative 5/3. All right, let's move on to problem number 10. So these problems look quite similar, but they're quite different in how you solve them. The first one is f times g of x. In fact, sometimes we write it with a dot in between, but it means the same thing either way. By definition, this is f of x times g of x. In this case, we have a binomial x squared plus 5 times the binomial 4x minus 3. Normally, we just put our parentheses next to each other. That indicates we're going to multiply. So we're going to FOIL this out. X squared times 4x is 4x cubed. X squared times a minus 3 is a minus 3x squared. 5 times 4x is 20x. And 5 times a minus 3 is going to give you negative 15. Notice we don't have any more work to do there. Now again, same thing happened here. This is B. G of f of x, that's how we read that. This symbol here does not mean multiplication. It's actually, sometimes we read it as G circle F. It's a small letter. It's not a letter O, it's smaller than that. So sometimes it's read G circle F, but the best way to read it is to read it G of f of x. It'll help you remember this means G of f of x. In other words, f of x will now be the input for the g function. Well, what is f of x? X squared plus 5. So x squared plus 5 is going to be the input for the g function. Well, look at what the g function does. It takes your x value or input and you multiply by 4 and subtract 3. And so I'm going to take 4 times my input and subtract 3. That's what the g function does. My input is x squared plus 5. So 4 times the quantity x squared plus 5 minus 3. I'm going to get 4x squared plus 20 minus 3, or 4x squared plus 17. Let's move on to number 11. So here we're supposed to plot the point 2, negative 4 on the graph. So I've done that. And then we need to find the point that's symmetric to this point with respect to the x-axis. That's letter A. Well, the x-axis is here, and if you reflect through that axis, you have the point 2, 4. So again, we'll do the same thing, but this time we're going to reflect our point across the y-axis. That's this one. And that would be the point negative 2, negative 4. And then finally, the origin, I would want to, you could draw this line, and the same distance on the other side, you would find the point negative 2, 4. That's the reflection of our original point through the origin. And so negative 2, 4 would be your answer there. Let's look at number 12. So here you're supposed to find the difference quotient for this function f of x equals x squared plus x minus 1. So we did this in 3 steps, and that's how I'm going to do it here. First, we're going to find f of x plus h. That's just this piece here, this part. Well, let's make a shell or a skeleton of our function. Notice we have our input squared plus our input minus 1. And so our input, though, here is x plus h. We're replacing all our x's with x plus h. So we need to find x plus h quantity squared. Let's FOIL this off to the right. So you're going to get x squared plus xh plus another xh. Notice I just wrote it in reverse order so you can see my like terms. Plus h squared. We've got 2 xh's, so it'll be x squared plus 2xh plus h squared. So I'm going to go ahead and replace that part. And then I've got plus x plus h. That's just plus x plus h. And then don't forget the minus 1. So that is f of x plus h. So next we're going to find f of x plus h minus f of x. We're basically finding the numerator now. So we're going to start with f of x plus h. We just found that. That's this right here. And we're going to subtract f of x. So that's f of x plus h. We're going to subtract f of x, which is x squared plus x minus 1. And so let's go ahead and rewrite this, but we're going to distribute the negative over here. So we're going to get all of this first part, and then it'll be minus x squared minus x plus 1. Now what we find is these 3 terms, once we distribute the negative, they all end up canceling out. So you should expect that when you're doing this kind of problem. So notice the x squared and the minus x squared, the x and the minus x, the 1 and the minus 1. So what's left? You've got 2xh plus h squared plus h. Now we're ready for the last step. So we're going to find the final answer, the difference quotient. It's going to be, notice we already have the numerator. That's what we did in step 2. So let's write that. Our denominator is h. So we can break this into 3 fractions. 2xh over h plus h squared over h plus h over h. You're going to end up with 2x plus h plus 1. H over h is 1. All right, let's move on to number 13. So on 13, we know to use the algebra test to determine if a function's even, odd, or neither, we replace x with minus x. So minus x cubed, well, if you multiply 3 minus x's, you're going to get a negative x cubed. And then you're going to have plus 4 times negative x, that's minus 4x. So notice each of our terms have the opposite sign now. So really this is equal to the opposite of the original function. This is the case, and you don't have to do this last step here. Once I see that these 2 terms have the opposite signs of the original, I know that I have an odd function, and that means we have symmetry with respect to the origin. Or for short, I'll just say origin symmetry. All right, let's do the same thing on b. We'll plug in minus x for x. Notice you're going to get x squared plus 2x plus 8 when you simplify that. That is not the same as what we started with. And in fact, it's not the opposite either. Notice only the 2x change signs. And so this is the case where we would say neither. It's not odd and it's not even. And we don't have any of these special symmetries. All right, let's look at C. We'll do the same thing. We'll plug in a minus x. And notice when you take a minus x to an even power, you're always going to get a positive. So this is just x to the fourth. The same thing here with the 3 times a minus x squared. A minus x times minus x is x squared. And so we'll end up with 3x squared there. And the minus 21 we just bring down. So you can see that we're back to the original function we started with, or h of x. And so this is an even function, which means we have symmetry with respect to the y-axis. All right, let's move on to number 14. So I'd like you to go ahead and try this one, and then I'll show you my answer. All right, so I got g of x equals the square root of minus x minus 3. And I would always encourage you to double check to make sure you have it right. It says it's reflected through the y-axis, and when you have the minus under the radical here, that's what it does. And then down 3 units, this minus 3 is going to cause us to go down 3 units. That's a vertical shift down 3. And so this is correct. On the other one, we have g of x equals minus the quantity x minus 2 squared plus 5. So again, let's make sure we've got this right. Reflected through the x-axis, that's what that minus does out front. Shifted 1 unit right, that's what this minus 1 here causes us to go 1 unit right. Remember, horizontal shifts work the opposite of what you might expect. Minus 1, I would think I'm going left, but you're going right. And finally, up 5 units, that's what this 5 causes. And so it looks like we're good. Let's move on to number 15. So write out in a complete sentence how the following graph can be obtained from this graph here. So go ahead and try these, and then you can look at my answers here. So for G, the first one here, the graph of G can be obtained from the graph of F by shifting it right 4 and up 9. On the second one there, f of x is x cubed. And so my answer here would be the graph of h can be obtained from the graph of f by reflecting it through the x-axis and shifting it left 5. Remember, you always do reflections before shifts. All right, that's it for the review. Let me know if you have any problems or you have any questions.